At first glance, this writing may seem unremarkable, but it was written entirely through thought. As the participant imagined writing a letter or symbol, sensors implanted in his brain picked up on patterns of electrical activity, which an algorithm then interpreted to trace the path of an imaginary pen.
We've learned that the control signals for limb movement are present even years after paralysis, which is really sort of fascinating and almost unexpected.
Henderson and other scientists with BrainGate, a research collaborative, have successfully decoded brain activity associated with handwriting motor imagery. Their goal is to help people who are locked in, meaning unable to move their bodies, communicate faster. One of their main subjects, a firefighter who is paralyzed falling while taking out the trash, works closely with Henderson.
So he, subsequently has been living with paralysis now for over a decade. He's really just a valued and indispensable member of our team.
Creating a successful brain-computer interface, or BCI, is a quest for several research groups and technology firms. While widespread use may be far off, these breakthroughs point to ways technology might be able to extend human capabilities. After 5 days of practice, the participant could type at 90 characters per minute, which BrainGate says set a new record for BCIs of any kind.
So with each of these new breakthroughs, we begin to learn more about how the brain processes movement signals and potentially even higher order things like decision-making, for example, or error detection.
While brain implants are invasive, the hope is that more research will result in better technology for the people who really need it. Dina Mitchell for VOA News.